Well, I appreciate everybody hanging in there for another talk. So I work for Hortonworks on the Hortonworks data flow team, and I've worked on a couple of these integrations between NiFi and other systems. So tonight I'm going to talk about some of the work I did between NiFi and Apex. Just show of hands, has anybody here already used NiFi or have any background with it? I'm kind of assuming not many people. Okay, one. All right, so kind of the way I was going to do is give some introduction to NiFi, just so that the rest of the talk makes more sense. I wanted to dive into this capability in NiFi that we call site-to-site, and that'll make a lot more sense when we get into the streaming integration and why that is. And then we'll talk about the operators that are in, will be in the next release of the Malhar operators, and then dive into a specific use case of kind of an example of how you could tie these technologies together in an architecture discussion. Just my background, I'm a NiFi committer and PMC member. I had joined a company called Anyara that was a company started to support NiFi by the original creators of NiFi. And that company then got acquired by Hortonworks, and we became the Hortonworks data flow team. And that's where we're at right now. And I tend to always work on these integrations between NiFi and other analytic platforms, different storage systems, HBase, Solar, syslog, things like that. Just kind of jumping into NiFi and what it is, I think when people first see it, they try to compare it to some of the other tools that are out there and try to figure out like what is NiFi. So it's all about moving data around and bringing data from sources to the platforms that do the processing and back and forth, right? And if you think about how this happens in a large organization without NiFi, it's probably a lot of different tools pieced together, right? There's probably custom scripts, a couple of different technologies, cron jobs, all sorts of things, moving data around this organization. And you might get something working, but you kind of don't really know how the whole system fits together. If things go down, you don't always know. It's hard to react to changes if you need to change it, right? So NiFi kind of grew out of the need to solve all those problems. Like, how can we understand this data flow across the whole organization? And instead of having somebody draw this diagram that gets out of date of how everything works together, we want to actually see the data flow. We want to change it. We want to be able to react. If somebody says tomorrow that this data source has to go over to this other system, we don't want to have to write new code, stop the whole system, do a deployment. We want to just make that change right now when the person says to do it and have that change take effect. So it's not a analytic platform or anything like that. The job is to bring the data to the analytic platforms. And so we'll walk through some of the core features of NiFi. Some of the terminology just to kind of get everyone on the same page. So a flow file is a message that moves through NiFi. And the name flow file doesn't really have any meaning. So don't think that file means you can only move files. Just think a message. It has a payload and it has attributes. And it's kind of like, you could think of like an HTTP message. It has headers and the content, right? The reason this is important is because the attributes are passed around in memory. So they let you do really quick, lightweight operations. And the content is only accessed when it's needed to. So if you're moving like a 1 gig flow file through the system, you're not always moving 1 gig around, right? You're only doing that if the processor needs to do something to that gig of data. But you might be moving it through all these processors, making decisions, only accessing the attributes. The processor is kind of the main component that performs work on these flow files. So it could be a processor that pulls data from somewhere, a processor that delivers data, or a processor that does some kind of logic in the middle, like transformation, filtering. But the idea is that it kind of acts on one flow file at a time, right? And between two processors, there's a connection, which you could think of as a queue. And these queues, we'll talk about this more later, but one of the cool features is you can have these different prioritizers on your queues. So you can make very fine-grained decisions at every point in the data flow as to like how to bring back certain data sets based on their level of importance or maybe their age or things like that. And then process groups is just a way to sort of organize your data flow. So I think like a common question we get asked is how to make multiple data flows in a single NiFi instance. We kind of view it as this one big data flow, and you can have these disparate groups that are not really connected to each other. Each group can then have like its own flow underneath that. You'll see some more about this later on. So this doesn't really do it justice, but it's just like a real small clip of the NiFi user interface where there's two processors drawn on the screen. So you get this canvas, you start dragging the processors on, connecting them, you start and stop them, and everything you're doing to them, like when you stop that processor, that's happening immediately, and the data is queuing up between them. And then when you start it again, that data is flowing through again. So there's also a lot of statistics and information you can get about what's going on in the data flow. So you can imagine a much more complicated flow here, and you have a pretty good idea of how things are connected, where there's problems. If any problem happens, like if one of these processors throws an exception, there'll be bulletins on that processor with the error message bubbled up. So you can immediately kind of glance at it and say, how does everything look? Is it working, right? And get a lot of information about it. And you can also take any part of your flow and create a template and share it with someone else. This is a really nice feature for debugging. If somebody creates the scenario and they say they have a problem, well, you just ask them, can you export your flow to a template? Give it to me, I import it, and of course there's like some settings you might have to tweak that are to each system, but you can see exactly what they were trying to do in the flow. So provenance is one of the kind of main features in NiFi. The idea of provenance is that we want to be able to track for every message, everything that's happened to it as it's passed through the system. So you can think about compliance scenarios where somebody comes back to you and says, we need to know if we delivered this data to the system because it shouldn't have went there or something like that. And we want to go back and see, what data did we actually deliver to that system? Or there's one specific piece of data that shouldn't have gone down this path, and we want to know it did it. So we can go into provenance and we can get this, we get this list of events, and for any event, there's also other advanced search capabilities, but if you drill in on any event, you can get this graph of the events that happen. This is a very simple example where we had a receive event, which usually means that a processor, data was being pushed to a processor. So you could think of like a processor that has maybe an embedded server. It's like listen for HTTP event coming in. It registers a receive event, and then a send event. I think in this case it was sending it to Solar. And then the drop event just means like that's the end of that piece of data in the flow. But imagine a much more complicated flow where one message gets divided into several or more messages. You'd see that fan out in the graph, and you could track it all the way down to the end, right? So this is a really powerful, even just when you're like starting out and building new data flows and you want to figure out what's going on in the flow. I use this all the time to just come in here and say, between two processors, what did the message look like? You can drill in on the content at each point in time and see what it looked like. So if one processor says, I'm going to convert this from CSV to JSON, and you want to know if that's working correctly, you can just go in here, look at the processor before that, see the CSV file, look at it after, and see the JSON, right? Getting into the prioritization that I mentioned earlier. So, at all these queues between the processors, you can configure the queue and set certain settings. So you can adjust the prioritizer. You can actually build your own prioritizer. It's not a very common extension point, but you can. But the ones out of the box are the time-based ones, and then this priority attribute one. But what this kind of lets you do is if you had, say, 4 or 5 different data sources coming in, and they had varying levels of importance, you could tag each of them with a level of priority, funnel them down together, and then configure this queue to order them based on that priority attribute. So that everything coming from source 1, if that's priority 1, will get pulled first from that queue. And you can do this sort of throughout your whole flow and create this very fine-grained decision.
So the data provenance, I'm really intrigued about that. Where is this data provenance actually stored so that people can look at it? Is it like a SQL-backed database, or?
I'll jump into it in an architecture diagram in a minute, okay. But just the quick answer is it's not dependent on any other technology like other data store. It's internal repositories in NiFi, but I'll definitely tackle that.
Thank
you. In terms of extensibility, the whole NiFi as a whole is built to be very extensible. So, everything, even the way that NiFi itself, the distribution loads everything that comes with it, is based on this concept. So there's 4 main extension points: processors, controller services, reporting tasks, and prioritizers. For any one of those things, you can build this NiFi archive, we call it a NAR, and deploy that into the lib directory, restart it, and then those are available there. It's using the Java service loader pattern, if you're familiar with that. And it's pretty straightforward if you're a Java developer and know Maven. There's a Maven archetype to get you going, and you can get something working pretty quickly. In the latest release, it's even easier. There's some scripting capabilities where you could just plug in like a few lines of Groovy, Python, JRuby, all that stuff right into a processor, and you don't even have to go through the Java model. But that's something to look into. There's some pretty cool stuff you could do there. Jumping into similar questions. So, what does the NiFi architecture look like? So a single node on the left is kind of your default behavior, right? If you just download the tar and start up NiFi, you get this single instance. It has a web server, embedded web server, which is Jetty, and it has these 3 internal repositories. So the flow file repository, think of that as the state of like every message and where it is in the flow. And it's like a pointer into the content repository, which is where the payloads of all those messages are. So as one of those flow files moves from processor 1 to processor 2, the flow file repository is being updated to say like where is it, what processor is it at. But it never necessarily had to read from that content repository unless the processor needed to read in that data. And the Provenance repository is where all those events are. So these are all like custom internal repositories that are stored on disk. Generally, like a high performance scenario, you can, in the configuration file, you can specify a disk to put these on. You can have 3 separate disks for these. In a clustered mode, when you scale out, you have this cluster manager, and then your slave nodes or your data nodes, right? And the cluster manager doesn't do any data processing, but it's like the central coordinator. It's basically where you access the user interface, and all the changes you make are then pushed out to the other nodes, right? But it doesn't do any data processing. And I think a big difference from the cluster in NiFi to some other platforms, so we're not taking the graph of processors and like dividing them up and running certain processors on one node, certain ones on another node. Each node is running the exact same flow. It's just the data that is being divided across the nodes. So it's kind of up to how you're architecting the system and where the data is coming from to determine like how that data is going to be divided up, right? If it's somebody pushing you data and it's like a protocol that can be load balanced, you could stick a load balancer in front and you'd have a processor on every node getting round robin data. If it was pulling data, there's different approaches you can do. But just keep in mind, so it's the same flow on every node. That's kind of the takeaway there.
So what is the granularity of your profile? Is it like 5 megabytes for 100,000 IoT message bash, or it is like 50 bytes for each IoT message?
It could be either. So it could be.
It is a lot of tracking if you go to that level of granularity, like
Yes.
bytes.
So definitely, if you're doing very small, frequent messages, then there's going to be a threshold, right, of how long you can keep that provenance data around and things like that. So there's, for each of those repositories, there's different like age-off mechanisms that you can control. So it's like we're not viewing it as where the permanent storage forever of every piece of provenance.
Keeping track of it, 50 bytes, that's
Right.
just a lot of
Right. So the idea is, so the questions are around the provenance data and for like high volume small messages, storing all that. So we would definitely have a time period where we could store that. And then if your situation was where you needed to keep that data more permanently for some longer period of time, there's ways of pushing those events out of the system to, you could build some other kind of custom data store, maybe like an HBase store or something like that. But yeah, so we view it as a certain time range, right, of that data that we can keep around.
So the flow file repository is replicated, whereas the content and provenance repository is completely local. Is that
They're each actually local, right? So if you think about a flow file, it can never actually move across nodes in the cluster because they're each running the same flow, right? So on one node, that flow file had to come from some source that either got pulled in or pushed in, and now it's on that node. It passes through the graph on that node, and then it's either, something's done to it, right? It's delivered to somewhere else. And it's never going to cross over to like node 2 in the cluster. So each one has its own repository.
Is there a versioning involved in any of these repositories?
I'm sorry, say that.
For flow file in particular, is there a versioning involved that
Version.
I push a new flow file and basically the older one remains there?
Yeah, you can. There's definitely a couple of different ways you can do it. So you can. Sometimes you might have a flow file and then you want to transform the content. So you're like overwriting the content with new content. Other times you might be spawning one or more child flow files off that one. So usually in that case, you'd create like n new flow files and you'd remove the old one. And usually coming out of a processor, a lot of processors allow you to route the original one somewhere, but also route like new ones that something might have happened to. Things like that. Okay, so that's kind of the quick NiFi like 101.
So I have a question. People on the webcast. So you mentioned here that the container repository and the flow file repository they are all local. So what will happen if one JVM or one host is down? How to recover from the failure?
Yeah, so there are a couple of things in the works to handle some scenarios like that. So right now, I guess the two scenarios that could happen is the cluster manager could go down. In that case, the data nodes still continue on processing fine. It's just you need to bring the cluster manager back up to access the interface. If one of the data nodes goes down, that node is down right now, like it's not replicated to another node, but that will be something that will happen is we'll have the ability to have replicas take over if one of the nodes went down. But right now, like if one node goes down, that is down until you bring that up. There are some things though that you can do like in terms of high availability where you could have like active passive clusters and a lot of it really depends on like where the data is coming from, right? And like how it's getting to NiFi. So you could have, if you're worried about running this in like a cloud scenario where you have like different zones and you're worried about, I don't want this whole zone to have a problem. There's a really long article that one of my coworkers wrote about all these different ways of architecting across zones. I think one of them was to actually split the cluster across zones. Another one is to have like an active passive cluster. So there are some things you can do today to sort of isolate, like narrow down what could really go wrong. But we do acknowledge that that idea of replication needs to happen. Okay, so site to site, we call this like direct communication between two NiFi instances. So a common scenario is that you have this like tiered collection of NiFi instances spread out all over the place, trying to bring data back to a central place. And you might funnel that through a couple of layers of instances, right? And so the way this works is there's two components that you can put onto the graph. There's input ports and output ports. And you can build a push model or a pull model directly between two NiFis. And this can work between two standalone instances, two clusters, standalone to cluster, like any combination, right? It doesn't matter. NiFi handles all that for you. So that's one of the really nice things. And if you are going from like a smaller standalone into a cluster, it handles the distribution for you. So it'll round robin the data between all the nodes. So you kind of get like that even distribution just by using this mechanism. So just kind of looking at how this works. And again, this doesn't have to be standalone to cluster. It's just easier to make diagrams like that. So this is showing a push model. So in the first NiFi on the left, you bring all your data to RPG, stands for Remote Process Group. That looks like a processor on the graph, but it actually represents a connection to the other NiFi instance. So you tell it the URL of the cluster manager or of the single instance, and then it communicates with it and learns about the cluster. So, pushing model, you have the other NiFi, has these input ports waiting to receive data, and it's distributing the data across them. In the pull model, it's sort of the reverse, right? The first NiFi brings data to this output port, and the data is sort of waiting there for something to pull it. And the second NiFi, if it's a cluster, it has each node pulling the data back, right? So typically, I think, I've seen more of a push model just because it lets the first NiFi make the decision about like where to push it, but really doesn't matter. And the reason why I'm bringing this up is because this is a cornerstone of the integration between NiFi and Apex. And so the site-to-site code that does that between two NiFis, it's in its own module that we call the site-to-site client. And you can use it from any Java program. So if you just wanted to write like a quick, simple Java main program, you could use it to either pull data or send data to NiFi. And it makes it really nice to integrate with something like Apex, where it wants to, have an input operator that pulls the data in, right? So that's going to kind of be the foundation of the integration there. Okay, so jumping into the operators or how this integration works. So like we said, we'll use the site-to-site client in the operators. We'll have input operators that can pull the data from NiFi into Apex, and then output operators if we want to send data back. And we kind of have this abstraction that you can pass around. You don't necessarily have to pass this around as a tuple, but one option is this NiFi data packet, which that's kind of like your flow file, right? So you're getting from NiFi the attributes and the content. And I think the nice thing about this is you can use NiFi to do a lot of the things that it makes easy, just like extracting values from text or doing some parsing and preparing data in those attributes without writing any code. And then by the time it gets to Apex, everything's set up, and then you can focus on more like the analytic part that you want to do, right? So you don't have to write as much maybe parsing code, things like that. So looking at the input operator.
Is that kind of similar to connecting by Kafka to Apex or?
It's similar concept to Kafka, right? So the question was, is pulling from NiFi into Apex similar to pulling from Kafka? Yeah, I think the overall concept is similar. Some of the differences are Kafka's not doing as much manipulation of the data, right? They're kind of like something delivers it to the topic and then it's available there to pull, but in the middle there, that's nothing's really happening there. So I think NiFi gives you that possibility to do things there. On the flip side, one of Kafka's advantages is it has the offsets, so the data is still available there and can, retry by resetting the offset. In the NiFi case, the site-to-site client does have a transaction mechanism, so it attempts to pull that data from the output port, and it then, once it thinks it's pulled all the data, it performs a checksum to verify it has it, and then confirms the transaction. So the data is not actually removed from that queue on the NiFi side until the side over here has confirmed that it has all the data and completed. So there is a mechanism there to handle that. So on the input operator side, sort of have like 3 levels here. The base class is this abstract NiFi input operator that provides the main interaction with like the site-to-site code, and then it delegates to like an abstract method to say how to actually create the tuples from what it's pulling in NiFi. And then we have the single abstract NiFi single port input operator, which adds the one output port. And then it's still waiting for another class to provide the implementation, which is the NiFi single port input operator. So that's like probably the most likely thing you would use is that last one there. And what that's doing is it has a single output port, and it's producing these NiFi data packets that you can then use. But these different levels kind of give you the flexibility where if you didn't want to produce NiFi data packets as your tuple, then extend one of the other ones and do something different, right? I know everybody, maybe not Java developers, I know it's hard looking at the code, but just like an example of how you'd use this operator, the main thing I wanted to point out was how you create this site-to-site client. So we have this builder where you specify the URL and the port name in NiFi that you want to pull from. So that URL is either the URL of a single instance or it's the URL of the cluster manager. And then, just for this example, I have the no-op data manager, window data manager, and then pass those in to create the operator. Here it's just hooking up to a console operator and then connecting them up. So it's just like writing out to the console each NiFi data packet. On the output side, similar, there's 2 output operators. Very similar. There's this concept of the data packet builder, which is sort of like the pluggable way of converting the tuples back to what you need to send back to NiFi, right? So it's like maybe I have strings coming into my operator, and I need to somehow turn that into the NiFi data packet that sends back to NiFi. And looking at this example, very similar, how you'd set it up. Here, this port here would be an input port on NiFi because you're sending data back, whereas the other one was the output port pulling it. So I think that's kind of the overview on the operators. What I wanted to jump into was kind of an example of how to, maybe integrate these technologies. And I think when most people think about how to use NiFi, it's usually about moving data from like sources that are increasingly getting smaller and smaller, driving it all the way back to a central data center, and then an analytic platform like Apex, right? So you kind of always think of this, or at least I always think of this left to right data flow, right? And increasingly, as you move out to the edge, getting smaller and smaller. And I think where it gets interesting is kind of thinking about this like back and forth flow, right? Like prior, it's always kind of been, well, once you get it to the data center, you do some analytics, and that's sort of the end. But you can really do some pretty cool things if you take those results and push it all the way back, right? So you can do some like dynamically adjusting data flows where you're using those analytic results to change what you're collecting, or change something in your data flow like all the way out at the edge. So I tried to come up with an example that, it's admittedly not really using the power of Apex probably, but it is a working example between the two technologies and just kind of shows how this could work. So I came up with this like log collection scenario. I know it's a bit to look at here, but I'll try to walk through it. So I guess the idea is you have these edge instances collecting logs, trying to bring them back to the central data center. And initially we're saying that we only want to collect like error messages and warning messages because we don't really have the bandwidth or the power to bring back like every log message, right? It'd just be too much. So going across the top, we're bringing back logs from an edge NiFi to the core. And you would imagine there's a whole bunch of these edge NiFis. We deliver those logs to Apex. We can then do like a window calculation to determine a rate of how many of those error and warning messages we're getting. And we'd have like some kind of user provided threshold that said, I'm just making this up. If I get more than 100 of those a second, then I want to stay at the same level because that's like my max I could accept. But if it drops way below that level, then well, okay, we're not receiving as many as we thought, so why don't we start collecting more? And we can tell the edge to adjust itself and start bringing back more. So the way we do that was, we'd use both sides of those operators in Apex to receive the logs, pull them in, do some calculation, and then write the results back to NiFi. And then NiFi would provide those results all the way back out to the edge. And I'll show what this looks like, exactly in NiFi and Apex. But so going across the top is kind of the bring the logs to the central location, then Apex sending back, storing the results, and then the edge instances will pull the central NiFi to say, like, give me your latest results, like what should I be doing, right? So kind of look at how this could look in NiFi. So this was an example flow from one of the edge instances. So going across the top, tail file processor, watching a log file, right? And I'm sort of assuming for this example, it's just like your simple Java logging with like log4j, logback, where you have info, error, warn, those types of things. Split lines, basically, if it grabs a file with a bunch of log lines in it, it splits them into one line per flow file. So now I have like one log message. Extract text applies a regular expression to each one of them and can pull out what is the level. So I basically want to identify the info, error, or warn, and pull that from the text up into an attribute so that it's available there. And then the filter log level is where we're going to be filtering initially based on this input of filters that's in a file that tells it, like, only let things pass through this that match the filters I'm interested in. And then that box on the right there, that's the remote process group that's delivering back to the central NiFi. And along the bottom here, completely kind of disconnected from this, is this two processors that are actually polling the central NiFi and saying, like, what's your latest set of filters that I should be using to filter things? So they get HTTP processor, you provided a URL, and you can set it on a timer, so like every 30 seconds, make a request. And it's actually calling to a service embedded in the other NiFi, and when it gets the results, writing it to a file. Those results are the same filters that scan attribute is using up there. So that's how it's kind of tied together. And then looking at the central NiFi, going across the top, it's just a pass-through, all the logs coming in, and that top output port there is where Apex would be pulling off that, right? And then when it's done and it writes something back, it would send it in here. Dictionary is just a term for the list of filters. Just, don't think too hard about that. And then it comes in there and it writes it to a file on disk so that it has it stored. And down here, basically building, this is one of the really cool things in NiFi. You could basically build a web service by just connecting these processors up. So this handle HTTP request is providing a web service at this port/dictionary. That path, and it's listening on a port that you can see in the processor. So that's how that other processor is calling over here and saying, like, let me retrieve your current set of filters. And it just goes and retrieves that same file that was stored and sends that back as the response. And then looking at this, kind of like the Apex application, again, it's not doing anything very complicated here, admittedly very simple, but just wiring up the input operator to pull in the data. There's this one log level window count operator that's producing, like, for this window, what are your counts of each level, and then the builder is actually determining the output of that builder. So if you look at this builder, the input is this log levels object, which is your map of levels. And then the output it's going to produce to send back is like this new set of filters. So it's either going to send back content of just error and warn, or it's going to send back error, warn, info, debug, and all the other levels, right? And then that'll go back to this output operator, and then write that back to NiFi. So that's kind of how you create, like, that full loop there. And just to kind of summarize, right? So you're sort of creating this full loop and adjusting, what's happening on the edge, right? And that's pretty much all I had. I think that's kind of the really interesting case is when you start doing something with those results. I put together that whole example there. I have that actual implementation with those templates for NiFi and everything, and some instructions that probably need to be made better. But you could theoretically try to get that running from that GitHub repository there. I'm trying to build out the same example with some different frameworks. So right now there's Apex and Flink. Maybe if somebody knows one of the other frameworks better and they want to contribute, that would be pretty cool. I'll take any questions anybody has.
Question online. Any questions on the webcast? Any questions on webcast, guys? Okay, cool. So thanks a lot, Bryan, and Ilya, thanks a lot. So this was our first meetup in this office. Hope to see you guys soon. We're gonna have a lot more meetups coming up. And meanwhile, make sure you get your t-shirts. There's still pizza out there. Yeah.